rolling factorials is where we do what we did before. See how we had 5 factorial equals 5 times 4 times 3 times 2 times 1? And see how we had 4 factorial is 4 times 3 times 2 times 1? Then what we can actually do is write 5 factorial as 5 times 4 factorial. You may ask yourself, like, why even bother? They're the same thing. Like, I know they're the same thing. We often, it's really hard to like make gestures and make that still be in the screen. We often have to cancel out fractions involving factorials. If this becomes easy for you, then it will make a few parts of extension 1 this year and next year easier for you. So, we're going to do a few things similar to this. Not only with numbers, but also with letters. And don't worry, we'll be doing these in painstaking detail. So, let's start off with this first example. We've got 10 factorial over 7 factorial. So we've got 10 factorial over 7 factorial. And these I do always tend to write out the question just to help me see it. Okay, well 10 factorial is the same as 10 times 9 times 8 times 7 times 6 times 4. I'm going to write this all out. You're going to learn a quick trick later. 10 times 9 times 8 times 7, couldn't I have chosen smaller numbers, times 6 times 5 times 4 times 3 times 2 times 1. This whole thing, that's not that bad, is over 7 factorial. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, you'll notice that all of these are multiplied. And just as with algebra, if we had like 12ab over 4a, you could cancel out the 12 and the 4 to be 3 over 1. And the ab and the a, you can cancel the a's out. If stuff's multiplied, you can cancel it out top and bottom. So we're going to go through and we're going to cancel out everything that appears top and bottom because it's all multiplied. It's the same as dividing it by those. So I'm dividing everything by 2, I'm dividing everything by 1, I'm dividing everything by 3, I'm dividing everything by 4, 5, 6, 7, etc. And what we're left with is 10 times 9 times 8. And that's it. Everything else has been cancelled out. And this is actually 9 times 8 is 72, times 10, 720. Another way to do that same question without writing everything out is this. So we've got our 10 factorial over 7 factorial. Now 10 factorial is the same as 10 times 9 times 8 times 7. I stop at the 1 that's the same as on the bottom. Or if it's on the bottom, you'll see. 7 factorial. Because when I had all of these, that is just 7 factorial. Let's go to the pen. And that's over 7 factorial. Now, have you noticed that we have something the same, top and bottom? That means we can cancel it out. So we didn't need to write everything out, that full expansion. And when you get the really large ones, or when you get ones with letters instead of numbers, so it's not generalized, it's not specific, it's generalized, you're going to do this. So that just gives us our 7 times 9 to, our 10 times 9 times 8, which is 720. Yes, you could just do this in your calculator, I know, but doing it in your calculator is not going to teach you what we do for the next one. N plus 2 factorial over n take 1 factorial. I'm going to rewrite this. So, we have n plus 2 factorial over n minus 1 factorial. Now, this is generalized with letters. It's harder to conceptualize, but just like 10 factorial was the same as 10 times 9 times 8 times 7, n factorial is going to be the same as n times the number below it, n minus 1, times the number below that, n minus 2, times the number below that, n minus 3, keep going. Don't worry, we don't actually write it all out. N plus 2, what's the number below n plus 2? So I've got my n plus 2. The number below n plus 2, so n plus 2, 1 less than that, is n plus 1. N plus 1, the number less than that is n. N, the number less than that is n minus 1. Now I could keep writing this out, but I've already arrived at the number that's on the bottom. So n minus 1, if I were to keep writing that, n minus 2, n minus 3, n minus... Actually, no, I really should keep writing that out. Otherwise, it's going to be confusing. So let me erase this. It works. So we've got our n minus 1, the number less than that, n minus 2, and you would keep going down all the way until it was like 2 and then 1. Now if we put that over, we've got our n minus 1. That's multiplied by the number less than that, n minus 2. That's multiplied by the number less than that, less than that, less than that. You'd keep going all the way down to 2 times and then 1. Just like with the question before, we're going to cancel out everything we see, top and bottom. So the 2 and the 1, all these numbers in between, they're actually the same numbers. N minus 2, n minus 3, n minus 4, n minus 5, n minus 6, n minus 2, n minus 1. And what we're left with is this n plus 2, n plus 1, and then you could put in brackets n at last or just put an n out the front. It really doesn't matter. We're not going to expand that. They would be mean if they expected us to expand that. So, just because we know how to do it, and why bother? There's an easier way to do this. Just like with the previous question, when we could just leave it at this 7 factorial and leave the bottom as it is, we're going to do that. That's the easiest way to do this question. So let's rewrite this out. N plus 2 factorial over n minus 1 factorial. And we're going to keep unrolling the n plus 2 factorial until we end up with what's on the bottom. So n plus 2, 1 less than that is n plus 1, 1 less than that is n, 1 less than that is n minus 1. And I'm going to stop because I can't bother writing the whole thing out. I did that before. It's a waste of time. All over n minus 1 factorial. So we simplify top and bottom. N minus 1 factorial, n minus 1 factorial. We're left with exactly what we had. And we write it out again just to be nice. And I'm going to write it this time n plus 2, n plus 1. Same diff. If you left it as this, n plus 2 times n plus 1 times n, or n times n plus 2 times n plus 1, any order, it's the same thing, you'd get full marks. Now, the last one's a bit harder because it's really generalized. N factorial over n minus some other number r. This is actually a very useful thing later on in this chapter. You're going to be seeing this a lot, but we're just going to deal with this at its face value. So, I'm going to rewrite this. We have n factorial. So this is just some generic number. It could be 8, it could be 17, it could be 332 million. Over n minus r factorial. So this is r less than n. So if n was 10 and r was 8, then this would be 10 factorial over 10 take 8 is 2 over 2 factorial. But we're going to make it really generalized so we don't have to deal with specific things and do it for every single case. So, n factorial. I'm going to keep writing this. I'm going to keep unrolling this. So we've got n times, what's 1 less than n? N minus 1. What's 1 less than that? N minus 2. What's 1 less than that? N minus 3. And I'm going to keep going, and I put dot dot dots every time I couldn't be bothered keeping on going, until I get to n minus r factorial. And that r could have been 2, doesn't matter. all over n minus r factorial. I mean, I could keep writing this top line out, n minus r minus 1, n minus r minus 1, 2, n minus r minus 3, all the way down to like 3, 2, 1. Why bother? We know how to deal with these. Okay. As you've probably guessed, this leaves us with these. Now, this time we are going to have to care about this dot, dot, dot. So we had our n minus 1, our n minus 2, our n minus 3, and we went all the way down to the one above n minus r. So you know how the one below n minus r was n minus r minus 1? Well, we've gone down to n minus r plus 1. Yep. That's it. I mean, I say that's it as though it's easy. It's really not easy. If you struggle with these, that's okay. Once it gets onto these really generalized ones with the letters, pronumerals, it's quite difficult. You will get there, I promise. Next time, we're going to add and subtract fractions with these factorials in them, and it's quite an exercise.